All right, we're going to look at a few normal distribution problems. So I have a copy of the practice test we're going to work with. Take a look at number 15. So here we're asked to take a look at thermometer readings where the mean is 0 degrees and the standard deviation is 1. Now that makes that a standard normal distribution. We want to find the probability that a randomly selected thermometer reads greater than 2.22. So greater than means we're looking at a right tail. So here, we don't have to draw it by hand. They give us the drawing, so we need to pick the drawing that represents 2.22 or greater. That would be option C here, and find the probability. They also tell us we could click and view the table. Now, my advice to you is to never use the table. It's a pain in the butt. It only works for z-scores. If you have anything that's not z-scores, which means the standard normal, then you have to do conversions back and forth, which is a pain in the butt. So we could scroll on to the next page, and you just click that button if you're on the online test, and we want to find the z-score of 2.22. Now the first page has negative z-scores, there's the positive z-scores, so I find 2.2, and then the top column would be 2.20, 2.21, 2.22, so on the third column in the 2.2 row. And so that says 0.9868. Now that's a left tail, right? The picture clearly shows it only finds left tails. So I would have to do 1 minus that to get the right tail. I'm going to use a spreadsheet to do it next. Let's see. So here, I'm going to use Google Sheets. Excel is pretty similar. I want to do a normal calculation. It gives me a bunch of options. On Excel, they have a dot, normal s dot dist, norm dot dist. So I'm going to choose norm.dist and enter my 2.22 x value. My mean is 0, my standard deviation is 1, and true, this is cumulative. With the normal distribution, you will never have anything but true there. False is completely meaningless to us. It just gives us a point on the curve as opposed to an area, which represents probability. We always want probability. So I hit enter, and like the table, it gives me a left tail. So I want to do 1 minus that to get the right tail. So the first one here is the probability that z is less than 2.22. Not what I want this one, probability that z is greater than 2.22. So 0.013-ish. And that's what you type in your little box for that one. All right, let's try another one. So again, I'd much rather use the formula on a spreadsheet or a calculator. As far as a calculator goes, using a TI, and somewhere on here is the option for normal. And as far as the normal goes, we're always going to use the normal CDF. The nice thing about the calculator is the calculator allows you to do two-tailed tests. So that can be pretty handy. So check this out if you're using a TI. I'm going to stick with a spreadsheet. Next problem. Let's take a look at. All right, so 16 asks us to do between two values. Okay, so we want z to be greater than negative 2.13, but less than 2.13. So we're in between those two. Again, I'm not going to use a table here. I'm going to draw a picture of what I'm finding now, and I'll find it. So I'm going to sketch out a drawing program, my best normal distribution, drawing with a mouse, my normal curve. All right, so make some notes on here. Right around here, let's say that's 0. So then we'd have, right here would be about 1, 2, and 3 on the other, so that's 3 right there. On this side, we have about -1, -2, -3 is around right there. So these are z-scores. Okay, so we want -2.13, so that'd be right about here. to positive 2.13, which would be right around here. And I want to find the area in between. So I want to find that area right there. All right. Now, keep in mind the calculator only finds left tails. So the way I'll do this on the calculator is the following. Let's see. Yes. All right. So on the calculator, I'm going to first find, because calculator only does left tails, right? Let's say this is negative infinity way over there. Oops, I kind of missed. Let's go right there. Calculator is going to find me that area first. Now that's more than what I want. So then what I'll have to do is tell the calculator to subtract from that the smaller left tail over here. So I'm going to take away this little part there, which will leave me that one right there. So I want to do the big probability first and then subtract the little probability. That gives me what's in between. So first I want to find normal distribution. Let's see, from positive 2.13, mean of 0, standard deviation of 1. And then I want to subtract from that next probability, negative 2. Norm dist, in Excel, remember it's norm, you can't spell, dot dist. Syntax is the same. It's going to be the x value, negative 2.13, comma 0, comma 1, comma 2. That is, and so the answer, so again, this one right here is the probability that z is less than 2.3. This is the probability that z is less than negative 2.13. Now let's subtract the two of them. I'll find the probability that z is between 2.13 and positive 2.13. So equal big one minus little one. And so my probability is 96.68%-ish. We'll go with that. All right, not too bad. Let's try another one. How about 17, like? We want to find out what thermometer reading goes with the 95th percentile. So the mark that puts 95% at the bottom and 5% at the top. So percentiles are always left tails, so that would be the picture D here. We want the area to be 95%, and we need to figure out what z-score makes that happen. So that's not a normal distribution, that's an inverse normal. To use the table for that, you'd have to go backwards. You'd have to find in the table 95%, which is somewhere in here. So according to the table, that would be 1.6, 0, 1, 2, 3, 4, and 5. So somewhere in between. So 1.645 about, and the table indicates that that is a very popular z-score. So I'm going to calculate that with Excel or OpenOffice Sheets. No, sorry, what am I using here? I'm using Google Sheets. All right. So next one, I want to find inverse normal. So I am going to say normal inverse. And the DI is inverse normal. And I'm going to go with the option here. And inverse normal wants to I need to give it the percentage. So 0.95. Mean at 0, standard deviation is 1. I think that's all it takes. Yep. And there's my z-score. A little more accurate than the table gives. 1.644853. More decimal places than I need, but that works. So that's the z-score that I want. So we just calculated here that the probability that z is less than 1.64485, blah, blah, blah. Is equal to that's what the inverse normal does. It gives us a z-score that goes with a probability. All right, so let's try another one. Not too bad. Okay, so here we have a situation where it's not a standard normal, so we have a different mean. The mean here is going to be 105, standard deviation is 20. We want to find the probability that a randomly selected adult has an IQ of less than 137. All right, so I'm not going to use a table for that. I'm just going to draw a picture and use my spreadsheet. So let's draw a new picture. It's supposed to be my axis, which is the straight line tool. And draw my normal curve. There's my best normal curve. Whoa, with the mouse. And here I'm going to draw my line in the middle. Alright, so that's the mean. Now normally it's a z-score of 0. Here I'm saying it's a mean of 105. And the standard deviation is 20. So that means one standard deviation to the right is going to be 125. Excuse my mouse writing. And then next to that, that will be 130. It's supposed to be a 3. So much better. Whoa, stop it. All right, so let's go one more. Gosh, that's not 130. What am I saying? That is 145. Standard deviation. Remember, z-scores just count standard deviation. So one z-score, a z-score of 1 is one standard deviation. And it's 145. Better one again. Okay. And now I'm looking for 137. So 137, if that's 125, it's going to be pretty close to the middle there. So it's going to be right around here. And I'll make a little mark over here so I can fill properly. Oops. Okay, that's closed off. Let's try that again. Alright, so the area I want is, again, the probability that a z-score is less than, let's double check I read that right, and probability that a randomly selected adult has an IQ of less than 137. Okay. Yep. So my area is, oops, I'm filling with white. Let's pick a different color. How about light blue? There we go. So here's where I believe 137 is. Let's draw that in. 1, 3, 7. All right. So fortunately, the spreadsheet does calculations just like I want. So normal distribution. And I want from 137 to the left forever. Mean is 105. Standard deviation is 20. This is cumulative. We're always going to put true here. Normal test. Probability is 94.52%. Alright, that wasn't too bad, was it? Alright. Next, and we're done. We got that probability. Always draw a picture with these to make sure you know what you're doing. Okay. Let's skip 19 and go to 21. Okay. Here, a safety light is designed so that the times between flashes are normally distributed with a mean of 4 seconds and a standard deviation of half a second. We're going to find the probability that an individual time is greater than 5 seconds. All right, so we need to draw that. So let's just scroll down here. So x-axis or z-axis. Normal curve. Best normal curve today. And let's see, I'll draw a line for our mean in the middle. mean is 4 seconds. Standard deviation is half a second. Okay. So there's my mean. So then 1 standard deviation to the right, let's say that's about here. 2 standard deviations, 3 standard deviations. Same on the other side. Z-score 1, sorry, -1, Z-score -2, Z-score -3. Now we're not doing Z-scores here, we're doing actual numbers. And so a standard deviation here is half a second, so that means this would be 4.5. And this would be 5. And this would be 5.5. And I want to know what the probability of the z-score greater than 5 is. All right, so that means on my picture here, I want to draw a line right through here. And I want that area to the left forever. All right. So remember on the spreadsheets, it does not, do right tails, it does left tails, so I need to do a 1 minus. So I'm just going to factor that right in. So I'm just going to go 1 minus my normal distribution, and I want to go from 5, and let's see, mean is 4, standard deviation is 0.5. So I get a probability for a tail of about 2.3%. 0.02275, around that to the nearest 0.1%. That would be 2.3%. Let's draw that in there just for fun. So 10. So this probability right there, probability that z is greater than 5 equals about 2.3% is what we just figured out. Pretty cool, huh? That's that tail there. Does that make sense that it would be that? Let's think about that for a minute. Always good to double check yourself. So here's 2 standard deviations to the left. Whoa. Oops. And I remember something called the empirical rule that said, let's pick a new color, how about pinkish. If you look within 2 standard deviations of the mean, then you should expect to find, anybody remember? Excellent, 95%. That's my best drawing with a mouse this morning. So if that's 95%, then the tails have to split 5%. Which means there'll be about 2.5% in each tail. Actually, it's more like 2.3%. Cool. All right, that's it for today. Have a good day. Good luck on the test. Have fun. Do good math. Bye-bye.